In the previous videos of Mastering AMC 1012, we covered many important concepts in combinatorics. But today, we're covering algebraic manipulation techniques. Make sure to stay till the end, as we'll explore how to use these techniques to completely simplify a complex problem into something we can easily solve. Okay, so to start off, we have binomial expansions. So we have binomial square expansions. X plus y squared equal to x squared plus 2xy plus y squared. This is very important and we'll use it in many problems later. But another important thing that's helpful to know is that it's equal to x minus y squared plus 4xy. As we'll also see here, x minus y squared is x squared minus 2xy plus y squared. And another useful thing is that this is equal to x plus y squared minus 4xy. We'll be using this to solve some hard problems later in the series. Also, it's good to know that x plus y squared plus x minus y squared, as you can see here, is just 2 times x squared plus y squared. So if we have the values of x plus y and x minus y, we can solve for x squared plus y squared from this. And similarly, we can also use x plus y and x minus y to solve for xy. So sometimes a problem might give you x minus y and xy, and you can use this to solve this equation here to solve for x plus y. And same thing, you can solve any one of these three quantities from the other two. Okay, so what about this last identity over here? X plus y plus z squared, all squared, is just x squared plus y squared plus z squared plus 2 times xy plus yz plus xz. This is very important when we're dealing with squares of multiple terms, and this can also be extended outward. Now we're ready to move on to binomial cube expansions. So x plus y cubed is equal to x cubed plus 3x squared plus 3x squared y plus 3xy squared plus y cubed. Now, notice that x squared y plus xy squared, well, there's a common factor of xy here. So that's just xy times x plus y. So therefore, we can rewrite it as just 3 times xy times x plus y. Also, we have x minus y cubed is equal to x cubed minus 3x squared y plus 3xy squared minus y cubed. Key here is it alternates signs. Positive, negative, positive, negative. And similarly, we can rewrite this as 3xy times x minus y, because xy are common between both of these terms. Right. So now here's another scary looking identity, but don't worry, it's not that scary, because all it's saying is that x plus y plus z cubed minus 3xyz is just x plus y plus z times x squared plus y squared plus z squared minus xy minus xz minus yz. So the way to remember this is that the sum of cubes minus 3, because we're dealing with 3 here anyway, so 3 times the product is just the sum times x squared plus y squared plus z squared minus the pairwise product. This may seem hard to memorize, but as you do more problems, it will become more familiar. So here's another useful property. If x plus 1 over x is a, what is the value of x squared plus 1 over x squared? So this is a very standard math competition problem. So essentially what we'll do is, if x plus 1 over x, we square it. We get, by our binomial square expansions, x squared plus 2 times x times 1 over x plus 1 over x squared. Okay, so notice that x, 1 over x cancel. We're left with x squared plus 1 over x squared plus 2. So if this is a, then this will be equal to a squared. So that means x squared plus 1 over x squared is just a squared minus 2. Now what about x cubed plus 1 over x cubed? Well, we can use binomial cube expansions. Take a look at this. We have x plus 1 over x, and we cube it by our binomial cube expansion. It's just equal to this. X cubed plus 3xy, or x times 1 over x, times x plus y, which is x plus 1 over x. Well, x times 1 over x, that's just 1, of course. And x plus 1 over x. Well, that's a, right? So we have a cubed, right? This is a equals x cubed plus 1 over x cubed plus 3 times 1 times a. So x cubed plus 1 over x cubed is nothing but a cubed minus 3a. Another thing, x to the fourth plus 1 over x to the fourth. Well, how do we do this? Well, we already know the value of x squared plus 1 over x squared. So let's just square that. If we square that, we get, by binomial square expansions, x squared squared plus 2 times x squared times 1 over x squared plus 1 over x squared squared. This is just 1. This is x to the fourth. And this is 1 over x to the fourth. So this is our expression here. And this is equal to, remember, x squared plus 1 over x squared is a squared minus 2. So this is a squared minus 2 squared. So to get x to the fourth plus 1 over x to the fourth, we just subtract 2 from both sides to get this quantity over here. Now you can memorize these, but it's really not needed as long as you understand the process we did to get there. Okay, now let's take a look at an example problem here. Suppose the number a satisfies the equation 4 equals a plus a to the negative 1. What is a to the negative 1? That's just 1 over a. So we have a plus 1 over a equals 4. Right? Okay, so we're asked to find this here, which is nothing but a to the 4 plus 1 over a to the 4. This is what we're trying to find. How did we get there? Let's do what we just did. Well, first we square it. A plus 1 over a squared equals a squared plus 2 times a times 1 over a plus 1 over a squared. This is just 2. And we know what a plus 1 over a is 4. So this is just 4 squared, which is 16. So we know a squared plus 1 over a squared equal to 14. 16 minus 2. Now we just square it again. A squared plus 1 over a squared squared equal to, by a binomial square expansion, a to the fourth plus 2 times a squared 1 over a squared plus 1 over a to the fourth. This quantity a squared times 1 over a squared, they cancel out. We're left with a to the fourth plus 1 over a to the fourth. This quantity right here, we just calculated to be 14. So we have 196 equals a to the fourth plus 2 plus 1 over a to the 4. So our answer, subtracting 2 from both sides, we get 194. And that's just an application of what we just saw. But it's not always just a direct application. Sometimes we have to figure it out on our own. Okay, we have here x minus 1 over x equals 3. Find x cubed minus 1 over x cubed. How should we do this? Well, we have cubes. Let's just cube our expansion and see what we get. X minus 1 over x cubed. Let's use our binomial cube expansions. This is x cubed plus 3 times xy, so x times 1 over x, And then from here, we just multiply it by x minus y. Like remember, I showed here, if we simplify this term over here, we get minus 3xy times x minus y by grouping xy together. So we can do that something similar here. And then that would become minus 3xy times x minus 1 over x. Right? Okay. So now what can we do from here? Well, we know that x times 1 over x is 1. And we also have to subtract, I forgot to mention it, minus 1 over x cubed term here. That's the last term in our binomial cube expansion, of course. So what is x minus 1 over x? That's 3. So we have 3 cubed equals x cubed minus 1 over x cubed minus 3 times 1 times 3, right? This is 3. Let's add 9 to both sides. Well, notice that this is just, that quantity was just 9. 3 times 3 is 9. So adding 9 to both sides, we get 3 cubed plus 9 equals x cubed minus 1 over x cubed. 3 cubed is equal to 27. So 27 plus 9 is 36. And that's the answer. So to summarize, we cubed our expansion term over here, and then we subtracted the leftovers and found them based on our original expression. Next, let's talk about factorizations. Quadratic factorizations. Well, I'm sure you've heard of difference of squares. X squared minus y squared equals x minus y times x plus y. And there's also difference of cubes, which is x cubed minus y cubed is x minus y times x squared plus xy plus y squared. Now the trick to remember this is that sometimes people also get confused with sum of cubes. And sum of cubes is x cubed plus y cubed is x plus y times x squared minus xy plus y squared. Okay. So sometimes people get confused. They flip up terms between these two identities. Now here's my trick to remembering them. When there's a minus sign here, the x minus y term also becomes minus. When there's a positive sign here, the x plus y term also becomes positive. But when it's minus here, then the xy term is positive, so it's flipped. This term here is always flipped from the sign here. And this term here, negative xy, will be flipped of this term. That's how I don't get confused between the two. And now, you might be wondering, isn't this the same problem we just covered? It is, and we'll be exploring how to use one of the identities we just learned to solve this. So we have to find x cubed minus 1 over x cubed. That looks like a difference of cubes, doesn't it? X cubed minus 1 over x cubed. And difference of cubes identity, x minus 1 over x times, remember, x squared plus its opposite of the sign. Or I shouldn't underline there, but this is going to be opposite of this sign. So times x times 1 over x. And that we add 1 over x squared. Okay. Now, how do we find this? Well, x minus 1 over x is just 3, right? What about this term? Well, we know x times 1 over x is 1. X divided by x is just 1. But we don't know these terms over here. How do we find them? Well, they're squares, right? Maybe let's square this. Let's take this squared. We have x minus 1 over x squared equals x squared. Remember, binomial square expansion here. X squared minus 2 times x times 1 over x plus 1 over x squared. And this simplifies to x squared minus 2 plus 1 over x squared. And this is equal to 3 squared, or 9. So this is equal to 9 as well, because they're all equal, right? So from here, we know that x squared plus 1 over x squared is just 11, which means that 11 plus 1 over here, because these two sum to 11 and this is 1, is 12. So 3 times 12, we get the same answer of 36 again. Two powerful ways to solve this problem, one using binomial cube expansions and one using difference of cubes, both things you should definitely know. Now there are also higher power factorizations. Now I know these look scary, but don't worry. They look much simpler when you see how they're used in actual problems. So let's take a look at the second one first. X to the n minus y to the n is x minus y times this giant thing. And I'm not going to read the whole thing out, so I'm just going to show you what it means in an example. Let's say x to the 5 minus y to the 5. In this case, n equals 5. So that's just x minus y. And the trick I like to use again, minus, minus. They're always the same sign for the x minus y term. And the thing here is, for the second term, it's going to be opposite. So because it's minus, it's going to be plus over here. So what we do is we say that all possible values such that the exponents sum to 4. Over here, this is a 5th degree term. This is a 1st degree term, or a linear term. So we need a 4th degree term over here. And the trick to remember is that this 4th degree term is just going to be all possible combinations. So x to the 4th, or x cubed y, or x squared, y squared, or x y cubed, or y to the 4. And this that's all there is to this term. And this applies to as large numbers as you need. Now there's also sum of odd powers. And be careful here. There's no expansion for sum of even powers. But there is one for odd powers. So let's take a look at x to the 5 plus y to the 5. This is a little bit more tricky. So same sign for the x plus y term. Now for the second term, because that one was plus, this term is going to have a little bit of minuses in it. So the trick to figuring out this expansion is to see that it's just going to be, again, this 5th degree term, 1st degree term, and this has to be a 4th degree term. So this will just be equal to, we'll again start x to the 4, and we'll again have x cubed y, and x squared y squared, xy cubed, and y to the 4. But the thing is, not all of these terms are going to be positive. They're actually going to alternate. So what we're going to do is we start at positive, then negative, then positive, then negative, then positive. So first term positive, second term negative, then positive, then negative, then positive. And that's it. We start positive and we alternate for the second term when we have sum of powers. But for difference of powers, it's always positive. Okay, now let's see an example of this in action. If x is greater than y, x plus y is 8, and xy is 4, what is the value of x to the 4 minus y to the 4? Well, this is just difference of 4th powers. Notice how we can write x to the 4 minus y to the 4 as, by our thing previously, x minus y, remember, same sign, x minus y times, now for this term over here, it always must sum to 3, the exponents. So x cubed plus x squared y plus xy squared plus y cubed. This is our expansion right here. Now what? We still have an x cubed plus y cubed term, and we only have x plus y and xy. How do we approach it from here? Well, if you remember the binomial expansions from earlier, this should look an awful familiar to the cube expansion of x plus y cubed. Remember, x plus y cubed is nothing but x cubed plus 3x squared y plus 3xy squared plus y cubed. This is very similar, isn't it? What are the extra terms? The extra terms are 2x squared y and 2xy squared. So if we just find these extra terms over here, then we can find this term here. So what is 2x squared y plus 2xy squared? We can pull out a factor of 2, of course. But now we're still left with x squareds and y squareds. Can we factor this maybe? Well, guess what? They both have a factor of xy, right? One is, so let's factor out xy. We have 2 times xy, 2 times xy times x, plus xy times y, right? Xy times x is x squared y, xy times y is xy squared. So this is equal to, we can combine the xy terms, 2 times x plus y times xy. You know x plus y is 8, so 2 times 8, xy is 4, times 4 equals to 64. Okay, we've found the extra part, finally. So now, we can finally find the second term, the blue underlined term in our expansion, this term. So, first of all, what's x plus y cubed? X plus y is 8, so this is equal to 512. And the extra part we have to subtract is 64. It's this term here. This is equal to 64. So we subtract 64. And this is just another mental math technique. 500 minus 64 is 436. And then we add 12, so 448. We know this term is 448. We're almost done. Now we have to find x minus y. Do you remember from earlier how if we have x plus y and xy, we can find x minus y, since we know that x plus y squared minus 4xy equals x minus y squared? X plus y is 8. So let's plug that in. We have 8 squared minus 4 times xy, which is 4, equals x minus y squared. Wow! 8 squared minus 4 times 4. That is 48. So x minus y squared equals 48. So x minus y equals plus or minus the square root of 48. Now, can it be negative the square root of 48? Let's read the problem again. If x is greater than y, so if x is greater than y, x minus y has to be positive. So we can completely disregard this negative. Now let's simplify the square root of 48. This is just equal to, the square root of 48 will just be equal to, well, notice how 48 is 16 times 3. So it's the square root of 16 times 3, which is just 4 root 3. So x minus y is 4 root 3. Now we multiply them together to get our answer of, now we just have to do 4 times 448. Now the way I would do this is 4 times 450 minus 4 times 2. 4 times 450, 1800, minus 4 times 2 is 8. So 1800 minus 8 times the square root of 3 is 1792 root 3. The answer, 1795. And we are done. Now we're moving on to algebraic equations. So we've got many interesting examples including some like this one that look complicated but are actually very simple with these techniques we're going to learn. But we're going to learn that all in the next video, which you can check out over here.